Happy Tuesday. Tuesday. Today, diving right in. Just going for it. Last week, when we were doing Monogame development, the last thing that we were doing was attempting to do a animation for the new flowers for our pollinators. So, wait, did I save it? Where did I save that? I saved it somewhere. I'm sure I'll find it. So anyway, I now have GIMP open. I have a sprite sheet open. We were saving that in a separate file. Where did I save it? We'll have to find that. Anyway, we created a few flowers as temporary sprites. We also had our fire animation. I didn't move those. Gotta find that. In any case, today though, what we're going to be focusing on is not sprite sheet work, which is this. Though we will eventually need to put some sprites in. The big thing we're going to be focusing on is coding an explosion of basically little dots, a little pollen that will explode in a radius. And it's going to have different, how big the explosion is depending on your combo level in the game. And particles will basically come into existence when the pollinator or the flower gets hit. They will go a certain distance depending on the combo level, and after that certain distance, they will go and be removed. So kind of cleaned up. So it's a purely visual effect. So that's our goal today, is we want to see how far we can get in making that happen. Now, I did mention that I have no idea where these are. I'm gonna do a quick check. I think I just put them in an images folder here. Let's see if I did that. It's definitely not that one. Is it that one? No. Put it in here. Date modified. No. Well, no. Sup, Nix? Today we're doing some Monogame development. When is your stream starting today? Where is this image? We saved this somewhere. That's not it. Details. Oh, there it is. I found it. There you go. Oh, very nice. Cool. This is how big it was. Oh gosh. All right. So what we did last week, we made these. This is the fire animation that we stole from stole and changed enough as temporary art from Super Mario Bros. 3 in the Dark World. Little fires. And then we made a couple of the flowers. We'll have a color for each one. So for now, why don't we just grab these guys and put them in our other sprite sheet, just so I have them. So here's our sprite sheet for our platform objects. Again, this is a gigantic sprite sheet, which has way more from a previous game that was in development here. So all the stuff we care about is kind of right up here in this top right corner. And I'm just going to put it right in here for now. I'm just going to put them down just to have them. This space isn't being used. So the big thing we want to do today, though, is, like I said, not GIMP. It's coding. So really, when we're using these dots right now, I don't care what the dots look like. We're going to be focusing on coding dots. They can literally be anywhere on the sheet, just any color. We're just going to choose probably an arbitrarily sized little rectangle. And our goal is to create an explosion of dots from a center of these flowers which right now just look like these bricks, and create them as they explode outward. But we will be using GIMP here kind of as an explanation for, as we're coding them, what kind of the behavior we want to do, which is this mess right here. This whole mess is that. So we're going to take this and delete this stuff, because we're going to be doing some sketch work later. So we're going to get started in just a minute. So we're going to go back to Visual Studio. So what do we need to do first? So first, what we want to do is take a look at the pollinator class. Now, I call them pollinators because that's essentially, in my mind, what it was like. Is that in the biofuels world of the game, because we have different worlds depending on the different types of energy plants. So in biofuels, the gimmick is that you have flowers that you hit, pollen sprays out, and it colors the bricks depending on your combo level. So we'll take a look at that. We'll just boot up the game in a little bit to see it in action. And we're going to be doing that throughout as we continue updating the code. So the big thing we're going to be modifying today is the pollinator class, but really we're probably going to be creating a brand new class within that. So we're going to go to here on the right, insert your objects, and it's going to do the classic just search. I think they're called biomatter. Bio. There you go. Did I spell that right? I don't think any of that's right. Why does it have an I? Pollen with an E? Anyway. So here we already have a few different color sprites for our flowers. Those will just be subbed in with the new ones that we have. And some of this stuff happens actually in another class. That's why it says here, this update method. It's actually done in the player class. Now, you might be asking, well, why is that the case? Right now, I'm just going to say, cuz, and move on. However, there are some important methods that do happen here in this class. One is changing its color and pollinating, which is kind of the big one. So what it does is it changes color to the color the player was. It will play a sound effect. Right now, it's just a dull sound effect. Eventually, there'll be a unique sound effect for it. And then it changes the color of the surrounding bricks. And that happens right here. So essentially, we're going to be creating one new method right here, which this is changing the color of all the surrounding bricks. And then we're also going to have a method that generates a bunch of sprites, which will be their own objects. And then those sprites are going to have their own probably update class, which will then move outward from the center of the flower. You're starting up soon, getting stuff set up? Very nice. So that's kind of the idea here. So when I code, especially when I'm creating brand new stuff, sometimes you just do comments like this, kind of plan out what you want to do. So here what we're going to have is we're going to have a new method. Some people actually just like, will have a bunch of red text, which means they might think, oh, well, what I want to do is generate pollen objects. And until that method is created, the game won't build. Or something like that. I usually don't work that way, but that is entirely an option. So we are going to have little objects that we're going to shoot out, and this class is going to have a list of them. And this class will dictate and kind of govern when those objects get created, as well as when those objects get destroyed when they're removed. So we are going to have something like this. Generate pollen objects. I don't know what they'll be called. And we're going to create a list of them. So what is that really need to be? What are we generating? Well, essentially, we're just generating a sprite. Now, it might be an animation, so it's probably going to be an animating sprite. Now, the animating sprite, it's going to be happening so quickly because it's going to be a really rapid kind of thing. And for that reason, having an animation tied to that, you won't even be able to see it. Like, unless it was like a lightning bolt that was kind of like going like that, you're not going to be able to see a tiny little dot actually like do something like that. That's why when we're looking at GIMP over here, here we are. So when we go like this, we could have something as small as like, you know, even if this was the animation, where it was like going back and forth between like a plus and a little dot, kind of like a little snowflake. Like, even that animation, you won't be able to perceive when it's that small and it's going that fast and it's moving. So we'll probably just start out with a dot, and then focus on its movement. For that reason, though, we still do want something that can move. So in the code base, I've created something called a sprite object. So let's take a look at what a sprite object is. Essentially, it's just a thing that has a sprite with it. So we have these things called interactive objects. So for example, this biomass pollinator is an interactive object. If we go to the interactive object, interactive objects are an abstract class. That means you need to inherit from it. You can't instantiate an abstract interactive object on its own. It comes from something called an entity. We go all the way to entity. This is entity is also an abstract class, and this is one of the core classes of the game. So entities have things like a sprite, a position, an original position, and all sorts of things like collision boxes and things like that. And it even has like a description here, a thing with a sprite and does stuff. You know. We have things called affectable objects. So here is trash debris. This was something in the previous game. What is an affectable object? Well, objects that could be affected by weapons, abilities, and other objects. So in the other video game I had, Blister Blight, you have things that could move something else. So things that could be moved by something else were grouped together into their own class. And everything affectable object inherited everything from interactive object. So what we're creating is something extremely simple. We just want to instantiate a little guy, basically a position with a sprite. And I think I do have something called a sprite object. Let's see if I do. Yeah, here we go. And a non-interactive object is called a sprite object. And why is it called non-interactive? Because, again, in Blister Blight, which is code base was based off of, was an action platformer, you'd have objects that you could interact with, like shoot a weapon at it, talk to it, like if it was like a sign, a whole bunch of things. And you had things that was just a background object. A non-interactive object in this game was basically something that could also move with layers. So there might be some, you know, stuff that moved in the background. What's called not parallelism, but where there's different layers of art as you're moving along. So that's what a sprite object was. Now again, a non-interactive object is an abstract class. We can't instantiate anything that's a non-interactive object. But a sprite object is essentially hey, what is a distance? It can move. Is it a canvas object? There's some stuff here. And then what was like the type? There's some type stuff too going on. Essentially, it was just a sprite. It also had an update. And the distance to move here, this was, again, all about moving something as the object moved and the camera moved. So even this isn't really applicable to us. So what I'm probably going to do, just for the sake of showing, I'll create a brand new object. And I think what we'll just do is inherit the entity class, which is a really base class. And go from there. Now we could do the interactive object class. I mean, there's way, way more here than we're going to need. Again, there's way more in this whole code base than we need. But these little guys, the big thing that we're going to need is the ability to update them. So we see entity here at the bottom. If we scroll down some, we have a abstract class called update, what it should do. And we have a virtual class draw. We also have some other stuff like playing sound effects and a bunch of other things too. So for funs, why don't we create a new class? Even though, you know, I may not be able to use an existing one, but that's fine. And we'll take, we'll just do it straight from the beginning. So we're just going to, normally what I do here is I copy an existing class and just modify it. So, you know, you could take like a really, really simple class and then just kind of modify it a little bit. So for example, what's a really simple interactive object here? Probably, well, this is somewhat simple. So this light beam is an object that has to do with the lights that are in switchball. So for example, I'm over here on the right. I'm gonna click. You can't see the little prompts that open up because it's streaming. And then I'm just gonna paste it inside interactive objects. Now again, this doesn't need to be an interactive object. It could just be its own little thing. But for simplicity's sake, we're just gonna over-engineer it a little bit. Sub-alpha paradox. So we're gonna go inside Lightbeam. This is our brand new one. And we're gonna need to call it something else. Right now, these are supposed to be flowers. These are supposed to be little balls of pollen. And we're gonna have a whole list of them. So what do we call that? A pollen seed? Pollen ball? We're just gonna call it pollen sprite. It's a little pollen guy. Pollen ball. Pollen. It's pollen. So then here it's going to have a little red line because it's like, what are you talking about? That's not the right name class. Pollen. Not much, got some boneless chicken wings. Yes, that is very true. Boneless chicken wings are just adult chicken nuggets. And again, we're inheriting from way too much stuff. We do not need everything in an interactive object. But I really don't care right now. I'm just I'm going to do it to go faster. Because in terms of the amount of extra, like, if you were really concerned about, like, performance of a game and, like, making sure you had the minimum possible stuff, or maybe you were concerned about someone coming into the game as another developer and like, well, why are you using this class? You could use this. It's way simpler. all that stuff is valid. For our sake here in stream, we're just going to over-engineer it a little bit. Interactive object has everything we want and way more. So all these sorts of sprites too. We are going to have probably different colors for the pollen. So this is also great because we're going to have probably a whole bunch of different sprites depending on the color of the pollen that's shooting off. So all this kind of stuff is great. We're not going to need an intersecting color type though, so we can go ahead and get rid of that. That was for the lights. We have our update class, which we're going to be using. And here, all this stuff was based off of this. So we can just go like that. Okay. So what we're going to do is first, we are probably going to do the pollinator class, because this is what is going to be shooting off these new little pieces of pollen in an explosion. Like a... So each pollinator is going to have a list of pollen. So here, we'll just do this at the bottom. A public list of pollen. And we'll just call it current pollen, probably, or something like that. And let's do a getter and setter. When the pollinator gets created, we want to create an empty list of this. So we'll do it down here. So I'm going to say current pollen is a new list of pollen. You do that so that if you ever hit like a list like this, if you haven't instantiated it, you'll get a object reference error. So here we go. We have a list of current pollen. So when do we want this pollen to shoot off? And that's when we hit the pollinator. So what I'm going to do is I'm going to boot up the game just to show that in action. And then we'll do a bunch more coding. I've yet to boot up the game, and on stream it's going to be completely out of whack because we were playing Ocarina of Time the other day. So let me show that. I think it's this. Nope. Yep. There we go. Here's the game. That's not too bad. I turned off the audio, other than sound effects. So let's go to the pollinator world biofuels. And we can see, we'll just do the very first level. Granted, they're not really ordered yet. This one's called transformation. And we'll start it up. So right now, we become red. And these little white blocks are the things that are supposed to be flowers. So you see that when I hit it, it turns all these cyan bricks red. And it just happens right now. So what we want to do is when we hit that block, we want to see a little burst of pollen come out, because those little blocks are actually going to be flowers that you're hitting. And once you increase your combo, which I'll do right here, see how I hit that and more colors changed? That's because the radius, as the combo went up, the radius of the pollen shooting out is going to go up as well. So right now I have a combo level of 1. Now I have combo level 2. That radius is now 3 bricks out. So we're going to have a pollen burst that is 3 bricks wide. So it can go up all the way to the maximum combo level of 10, which is very hard to reach. It's very rare for there to be enough bricks in a level to have 10, let alone have pollinators there. But you see this one is huge, huge burst. So that's what we need to animate, is we're going to be animating basically a particle effect of pollen shooting out from the center of these guys. So we can go ahead and close the game. So that's what this pollen is going to be, is we're going to be creating a bunch of objects. You love this game? Yeah. Alpha Paradox was actually one of the early playtesters. So there will be more playtesting once this is one of the final updates that needs to get in before playtesting. Again. And actually like the main playtesting. So we're going to scroll down here. And when is this going to happen? Well, you saw that when we hit the pollinator, that's when the burst should go off. It's going to be super fast, too. And we can dictate the speed as we tweak it. So when does that happen? Well, essentially, it happens when this method's being run. And that's why we put this here. So generate pollen objects. So why don't we go ahead and create a new method. Now there's a couple different ways you can do it. You can just do a public void whatever. Visual Studio also has different things in here. So if this doesn't exist, you can click on this guy over here, which again, you can't see anything, and say, hey, do you want to generate a method for that? I say, sure. It generates a method right there. Let's make it public. Now granted, this could be a private method because there's probably nothing else in the code base that needs to know about this method other than the pollinator itself, but I'm just going to make it public just to give myself a little bit of flexibility. So generate pollen objects. So the amount of pollen objects will probably change depending on the combo. Because say that you have a, this is where we're going to open up GIMP. Or at least show GIMP again. So say you have, we'll just choose, I don't know, like a blue. And this is our flower. This is great. Just take one of these. Here's our green flower. Put it over here. So if we have a combo level of 1, we're going to want some amount of little dots. Oh my gosh, GIMP, come on, work with me, bud. So a little dot here, little dot here, and they're going to start right in the middle. And they're basically going to be moving out in like a radial direction. These are arrows. This way. Now, I kind of want them also to move in a curve, so maybe like a sine curve or a cosine curve or something like that, so that the pollen is kind of wisped out like this. So then at combo level 2, it would be even further out. And then combo level 3 even further still. However, as the radius of these things gets larger, you kind of need more objects to be generated in order to kind of see the effect. So, you know, if you only have a little space, you could use like just 3, 4, 5 around it to look good. But as it gets bigger, you might need 10, 11, 12, 20, whatever. So something to keep in mind as the combo level. So things we do need to know are the player's combo level, because that is going to heavily dictate the behavior of these objects. And these objects are going to have probably some attributes depending on the combo level. It could be parabolic, yeah. If we didn't want it to be like a little, it could be both a parabolic arc. We could do like a little wave arc if we wanted to have some vibration to it. It could be exponential. So anywho, but yes, you're right. An arc like that is more parabolic. So what we're going to do is you're going to say, just create a new variable here. Current player combo game state. dot instance dot player combo level. The combo level, again, is going to dictate all this kind of stuff. And we'll probably, in the well, how do we want to do it? Why don't we just say for each combo level, we create, I don't know, we'll just start at 5. Why don't we do 5, 10, 15, 20 or something like that? So your base combo level is 0. So at 0 combo, it goes 1 brick out. At 1 combo level, it goes an additional 1 out, further and further and further. So what we're going to do is just say our current pollen. Now, this is the trick too. There's a possibility that you could hit a pollinator multiple times before the pollen is finished doing its animation. So that's something that, like, hey, if we do that, we probably just clear out whatever's left and start fresh. So what I'm going to do is first I'm going to say clear this out, which basically means, hey, the list is now empty. So if it was in the middle of an animation, you hit it again somehow. I don't know how that would be, because I think this is going to be super fast. Go ahead and make sure there's none there. And what we're going to do is our var pollen num. And what we're going to do is we're going to do 5 plus 5 times our current combo. So at a combo level of 0 at the very beginning, you'll have 5, and then for every one after that, you're going to create a new one. And then you can just do a very simple for loop. And you can just say for I equals 0, I is less than pollen num I plus plus. And we'll just add a new one. So we'll say there. And again, some of these lines could be a little bit more, like you could probably just do current pollen, do it all in one line. We're doing multiple lines here just to make it a little bit easier to see. So we're going to say var new pollen equals new pollen. Now, when we're instantiating a new piece of pollen, we do need some variables. So we need a sprite for the pollen. So we look at our pollen class over here. We have to have, what is its sprite that we're passing in? Now, a lot of these sprites actually for pollen are going to be dictated based off of what color they are. And that is going to probably be updated later. So you can see it has a color type. That color type is actually going to be dictating what's being passed in here. And the color type, I think, is part of, yeah, we're going to be passing in the color type. So here we can just do a new sprite. It's just going to be overwritten. What is its starting position? So its starting position for the X and Y, all of these new pieces of pollen ought to start in the middle. So we're going to have each one start in the middle. And then depending on, I don't know, we're going to have some sort of ordered list. They're going to be going in different directions. So our pollen, our little flowers, I mean, are 16 by 16 sprites. So it's just going to be, the starting position is going to be a new vector 2. It's going to be our biomass pollinator, the flower. It's going to be its position dot x plus 8 and position dot y plus 8. Let's do this to make it a little easier to see. So what else do we need? We need the width and height of these guys. Right now, I don't know. I'm just going to make them little 3x3s. And the color is actually going to be the color of the flower. So it's going to be this color type. Cool. So then what we're going to do is we're going to do current pollen. Oops. Dot add new pollen. So there you go. So we're creating a number of them equal to the player's combo level. We're setting position to the middle of the flower. We're just going to say they're 3x3s right now. So if we open up GIMP, they're going to be something along this size. So a little 3x3 rectangle. And we're going to add them all to our current list after we've cleared the list. And this generate pollen objects is going to happen when we've changed our color and pollinated it. Great. So we've created all of our objects. Now, what do we do with all of these current pollen objects? So now we need to move them and we need to draw them. That's kind of the essence of everything. Everything when creating the game. You created something cool. Nice. Now what do you got to do? Move it and show it. So we're going to show it whenever this is being shown and whenever the objects exist. And then we're going to move it every frame for a set period of time. So here we have a draw method. We also have an update method, which isn't being called. It's kind of interesting. That's fine. Welcome back. And because this update method right now is done in the player class, there's a lot of stuff that's happening. So why don't we actually show that? So I'm going to close out. We were doing a lot of work on menus and stuff. I'm going to close everything here. Top. So let's open up the player class. Here. And I'm just going to look for pollinator, or bio. There you go. Oh, it's checking for collision. Interesting, yeah. And we're going to go down. There we go. So every time it's going through and checking for collision, it's checking for things like lights. See a light source here. It's also checking for these pollinators. And it's checking whether to call this method change color and pollinate. However, now these pollinators aren't just need to be checked when the player might collide with them or is colliding with them. They need to update in order to update the pollen themselves. So there's really two choices here. We can say that what we've done is we're saying that this biomass pollinator is basically running or governing, or I don't know, there's a lot of different ways to say it, the pollen objects. And that's why we provided this list of current pollen. And that's what we want to do. However, we need some way to update all of these flowers, otherwise as known as pollinators. That's done in the level class. So the level class dictates what are all the things in the level that are getting updated or drawn at any given time. So let's go to the level class. Because I'm pretty sure this is already happening. So we go to bio. So you see here, we already have a list of these guys. And we're going to go down to the bottom. And here, this level class, all it is instantiating them, creating a new list. So the level class is abstract, has a ton of stuff. I'm just going to go to the top. Oh, never mind, it's not abstract. You can't call it. Anyway, it's fine. We only actually have one thing called a current level class. Originally, there was going to be an idea for multiple types of levels, say level. Sometimes you core level. You do a thing and you keep working on a thing, and the amount of refactoring it would take to change the thing is not worth changing the thing, and then you refactor it a certain amount, and then it's fine. So here, tons of different objects. Again, a lot of these from Blister Blight, the other game. We go to the bottom, and almost every object in the game has their own for each loop. There's an if statement, which says, hey, do we even need to update this object right now? Basically to save on performance. It's going to go and update every single one. And then it's going to be later drawing every single one. So we're already doing this. So essentially this update method is being hit every loop for all of these guys that happen to be in the level, but it's doing literally nothing. What's great about that is now we can have it be ready to actually do something. So that's what we're going to do. So here, we're going to say we're going to update all pollen objects if they exist. And then down here in draw, we're just going to note draw both the pollen. Why did I do it with an I? Is that right? I must have looked it up. Or I just made it up. Okay. So why don't we do draw first, actually. So you can see each of these has their own sprite for each of the different colors. It's also a default. Because if you've yet to hit the flower, it's going to be this little white flower, kind of like waiting to be colored. Depending on the color is depending on the color of the pollen objects as well. And it's kind of a choice here. We're doing a switch statement. Probably we'll do just another switch statement. No, the pollen class itself will dictate how it draws. So all we're going to do here is the pollinator. Yes. We're just going to do a for loop, or for each loop. Let's do p.draw. So it'll loop through the pollen and draw it. And we're going to do the same over here for our update class. Update all the pollen objects. And we just do a for each loop. Now, for each loop, if there is nothing in the for each loop, nothing will happen. So if this happens to be empty, it'll be empty. So we're just going to say p.update. That's basically all we need to do. Say, hey, whenever you're updating each of these guys, update all the pollen and also draw them down here. Everything else is going to be dictated by the pollen themselves. There is, however, going to need to be some sort of information, of course, to tell each piece of pollen, well, are you going up? Are you going right? To the left? So that's what we're going to think about now. Is now we have these pollen, which we need to designate the sprites and stuff, of course. But these guys need to know what direction they're heading and how far they're heading. So that's what we need to do now. So with this, each piece of pollen needs to know that kind of stuff. So there's a few different ways we can think about direction and all that and distance. But first, why don't we just make sure that they're getting the right sprites. So we have our off. We actually don't need an off sprite because if you're shooting off pollen, that means you did interact with it in some way. So we just need each of the colors. And here, like I said, these are just going to be 3x3 objects. So what we'll do is each of these is pulling the sprites from here. If we go to here, it's pulling stuff from here. So what we can do is just, we want the general color of the object here. So why don't we go ahead and just, I don't know, do some spot here in the middle that just will have a 3x3 color. So all these are 3x3. And we're not going to grab the corner. This is the corner of it, because then we just get a bunch of empty white space. So we'll just do, I don't know, something like 8x8 over. So why don't we make this, I don't know, 152. Oopa. What's great about this is we don't even need to update the sprite sheet to test this. We can just do it. And we'll just say this is 584, 600, 648, 632, 616, and 664. Okay. So we got our sprites. Next up is understanding the direction and how far they move. So how do we want to do that? Well, we can set some variables. Let's go ahead and hide GIMP. Oopsie poopsie. Back here. So I was hiding that. Oops. We set all of these to 3x3s. And then we set the X and Y here. To just be a little bit, so they're right in the middle of those. So each piece of pollen is going to have its starting position, and it needs to know the direction to head in. So this could be just a vector. Like it could have a, basically, what it probably ought to do something is like have a starting position and an ending position. Or, yeah, there's probably needs to be some sort of ending position. or just a general vector, like a movement vector. Or it could be a time. Maybe it just moves over a period of time. Because each explosion is going to take the same amount of time. So we can take that amount of time, know where we want, and just move the pollen in a motion radially. It might be radians. If you think about a circle, you can think about degrees or radians, like 360 degrees. It's probably a degree. Yeah. Make it a float for now. We might need to convert it to radians. But if we have a circle, like this, here's our beautiful circle. And, you know, oopa, oopa. You know, if you have a particle that's shooting out this way, or this way, or this way, or this way, somewhere around this 360 degrees, we want to divvy up the direction that that's sending the particle in. So I think, yeah, we can have it as a float for degrees, but eventually it might be converted to radians. So why don't we have a public float degree launch angle. And there's probably going to be a timer, which is probably the timer of, well, we can mess with it. The timer will be dictated in the biomass, like the flower, and it will continue updating until the timer's over. So why don't we do it that way? So we're going to have a time start and a time end. There's a lot of places in the game where I do kind of time start end coding, because there were a lot of weapons in the previous game that kind of said, hey, this should appear on screen for this period of time. So I'm going to look up one of those really quick. Actually, we're going to go into enemies class. Let's see if we can find something here. Oh, like this one. So we have this time. There's going to be 2 time spans. We're just going to steal that. We're going to have pollen start time. And we're going to have a pollen end time. And we're just going to dictate how long the default is for that. Maybe it will be like a ½ second, like this. This is just a ½ second. We can make it a full second if we want it a little bit easier to see, but for now we'll just do that. And then where else was it implemented? Down here. How did it do this one? If the end time was greater than the start time. Oh, that's an interesting way of doing it. And it reset it. Alright, so this is one way of doing it. It said after the end time was greater than it, it set the elapsed time and let it continue. But we can figure it out. I don't want any lyrics. Sorry, I skip music. I think there were some simpler ways of actually doing that. Let's see. Time until weapon. No, it's all doing very similar stuff. Okay. Just copy this in. Okay. So we have our start and end time. Start. Start. And I'll explain what's going on in a sec. Okay. So our end time is set to half a second. So here, it's saying as long as our end time, which is 0.5 seconds, our start time starts at 0 seconds, we're going to constantly be adding game time to the start time. So every frame that this updates, we're adding our game time to the start time. At some point in time, love English, our start time will be greater than the end time. Basically, once a half second has passed. At that point in time, do the thing after half a second. So if you wanted something to happen like every half second, in this case, our do the thing would be, hey, all the pollen's got to stop moving and delete it. Then reset it. So here, this while the half second is going on, that's when we want this whole thing to happen. We want them to update. So we're going to be putting this inside of this. So while the end time is greater than start time, go ahead and move the pollen. When it's all done, we're going to reset it. And here we are going to go through each of the pollen and clear it, or we can just call clear. So we can actually just do this. Just clear the list. It's no longer going to update anymore. So now we basically set a timer of half a second, and we can make it a full second. Maybe we'll make it a full second just so we can see it a little bit easier as we test. That says, hey, during that 1 second, the stuff will update. After a second's done, it'll be cleared. Close these guys out. Cool. So now we know that this stuff will update for a second long. Next step is we want to know the angle. So here in the pollen, we said, well, what's the degree launch angle? How are we moving? So we need to set that degree launch angle. And then here we're going to need to actually update and move the sprites. So we need to move the pollen based off of its launch angle. So we're going to go here, and we're going to go to where it's generating our objects, which is right here. So we have some number of pollen. It's going to be 5, 10, and this was arbitrary. It could be 6, it could be 12, it could be 35. I don't know. The angle, though, is we want it evenly distributed around 360 degrees. So we're going to get our number. We're going to divide that, divide each one, and know how many degrees to give to each one. We could put it as part of the instantiation of pollen, is to say its launch angle. So, for example, we may as well just do that. Say, well, no, in order to instantiate pollen, we have to pass in its launch angle. So we're going to say, what is the float launch angle? And then we'll just set our degree launch angle equal to our launch angle. So then back here, it's going to be like, hey, you're not passing in a launch angle, yo. So right now, we'll just pass in a default of 0. You could also make a default of 0. So when you're instantiating methods, you can have some defaults. So what we're going to do is our initial launch angle is going to be, I guess, 0 to the right. And it'll go around. So what is the chunks? So our var segments is equal to 360 divided by our pollen number. It should be a float, yeah. So why did I put an F? I put an F to dictate that 360 should be a floating point number. Because if I did, let's say, like 360 divided by something and got a bunch of decimals, if it assumed it was an int, it would truncate those decimals. And right now, I want to make sure I'm getting a floating point number, the closest it could be at a launch angle for our degrees. So here, if I did 360 divided by 5, that is what? 72. So our launch segment is going to be 72. So then as we go through I here, we are going to be passing in, basically we can do I times our launch segment. Except we're actually going to do, because we want to make it clean, we'll just start at I equals 1. Do less than or equal to. So then we can do that cleanly. So in here we can just do I times our launch segment. So our first one will get whatever it is, in this case 72. Our second item would get the next chunk. And each one is going to get its own angle based off of the number of pieces of pollen sent away. Cool. So we got our pollen, and now we have a launch segment based off of the degrees around a circle and our number of pollen. Cool. We got a launch angle. So how do we move the pollen? This is the last thing kind of we need to do. This pollen's got to move based off its launch angle. So we could try to do like a parabolic sort of movement. So each of these pieces of pollen has an x and a y coordinate. So for example, if I just did like var position x equals position dot x and var plus y, you can see that this stuff exists. Now the position x and y of any given thing is a floating point, and it can move in the x or y direction any floating point distance. So there are some other objects I've already moved in the code. So when you're coding something new, sometimes you can just, like I've been doing here, you're just coming up with stuff, you're coding it. I would encourage you to do that as you're learning and not rely on things like on AI resources. If you want to use an AI resource to let you learn how to do something more complex, or a place to start, that's great. But you're not actually going to learn anything if you're just letting it code for you. So I use AI a lot to do something more complex, like that I've never learned before. But if you get AI to write something for you, read the thing and understand what it's doing. And that's why, I haven't used it today at all. You also can reuse stuff you've made before as a reference. And that's a big thing in coding, as well as really any part of creative work. Is, oh, I did this before. How did I do it before? So that's what we did today. Is I was like, well, I've done timing before, and I didn't quite remember how. And then I was like, oh, right, this is how I did it before. I just had an end time and a start time, and it added game time to it. So we can actually do that for this sense of moving something in a parabolic angle. I've already done that a few times in this game. There are weapons in the previous game that had arrows as well as missiles that moved in a parabolic arc. So all I have to do is kind of look to see how did those things move and do something similar as a base. So for example, if I go over here to our weapons, make this a little bit bigger so you can see it. I'm going to go down to the homing missile. Homing? I want to do a homing one. No, spiral. So the spiral missiles were shot off and they kind of did a spiral like this. And that's kind of what I want. You can see here I have things like an origin, a circular speed, a radius, a rotation angle. Ooh, that's what we got. But that rotation angle is rotating the sprite itself. And a whole bunch of stuff it's passing in. So our big thing here, you can see I had commented out some stuff, sines and cosines. We had a radius. And let's see what it's using. So here's our angle. Our rotation in degrees. I was taking this angle. Was this angle? No, this angle was oh, this is for the rotation. I was saying how much do you rotate based off the angle? And then where's it actually moving it? Is this all based on drawing right now? No. Projected position, this is it. Interesting. Alright, let's take this. So it had an origin, had an angle, and the radius of the circle. So right now we have degrees, but we didn't say, well, how long is the radius of the circle that we're kind of moving? That radius is actually kind of going to be important because it's moving in a direction, but we kind of want the pollen to move a certain distance during that 1 second. And you could say, well, that could just be dependent on the speed. You could also do a formula, distance, velocity, acceleration formula to figure that stuff out. But yeah, there's a few different ways to do it. I'm going to go back to this guy. But the spiral missiles, they were moving very slowly. And they were slowly moving out in like a spiral pattern like this. Like, whereas ours are going to go really fast. So, to be honest, all this stuff might be over engineering. But we can just do it for funs. Let's do it for funs and see what happens. We're not going to be rotating our little squares, so we don't need to worry about that. But we'll take all this stuff. We'll just copy it in. My music stopped because I skipped one track, and then it's like, you skipped a track. You must not like this anymore. Let's do jazzy beats. Switching it up. Okay. So what are the things we don't have here? An origin. I have anything. Wait, we have our angle. We have our angle. What is this? Bada bing. Just fill in that. It's our origin. Let's take a look at this. Where was it setting its origin? Its origin was its position. Okay. So really its origin was its original position. Which is good to know. We need to set that. So we are gonna have, we'll just do it all. We'll have some fun. It's gonna go moving so quick. But we'll just set our origin equal to our position as well. Because our position is gonna be changing, our origin is not. What else do we got here? A projected position. Why don't we just... Why was I doing a projected position? Oh, we had movement vectors and... Previous position? We had a previous position and a projected position? Again, might be over engineering, but whatever. I'll just do it. We can always remove it if we want to. It's just the fun about coding, you can just do stuff. Then we have our angle. This is our launch angle. Angle. There we go. And our radius, it's just going to be kind of the distance that we're moving. It's going to go up here. It's a float. We also have a float of a speed. Cool. Do I set those probably to 0 or something like that? Oh, I had a default speed. Interesting. Cool. It seems so slow. We'll make it faster. It's going to be interesting. It's going to move so slow. Okay. So now there's all this sort of stuff going on. It's adding its speed to the angle. It's like doing stuff, right? So you might be thinking, what is this doing? I'm like, it's doing something. It's definitely moving it. I think it's moving it in like a spiral pattern pretty slowly. And all of our launch angles are different. And, oh, we don't have a default anymore. What should our default be? Let's make it blue. I don't know. Just put in a default. It's not going to hit. Okay, are we done yet to try it? So we have our color. It's being drawn. It's being updated. We're setting everything here. We're getting it from our sprite sheet. Over here in the pollinators, we're running this object, or this method whenever our pollinator gets hit. It's going to clear it out. It only does this as a check just in case there's still stuff that appeared on screen before it finished running. It's splitting it into segments, all the different pollen. It's creating a set number based off of the combo. And then on update, over the course of 1 second, we are going to be going through each of them and updating them. Now, one of the things you might notice here is that it's doing this every single time. It's constantly running this. And we actually don't want to do that. What we want to do is say if there are any of these. So we want to say if current pollen.any we want to do this. So when updating, if there's any current pollen, which means it was hit, go ahead and run the timer. When the timer runs out, all that pollen's going to clear, so then this won't get hit again. And it's going to reset our variables to 1 second. I think we're ready to test it. Go for it. Let's go ahead and hide VS. Let's go ahead and turn off the music. And let's try it out. Why don't we go to 1? Let's see here. I'll just do this one. Fine. Simple. All right. So, is it gonna work? What we're expecting to see is little red particles to shoot out in a spiral pattern at some speed for a second. Something happened. Look, little things are coming out. That was interesting. No, it's kind of hard to see. Alright, it's still happening. It just looks like one big blob. That's good. That's progress. It is happening for only a second. Let's see if the blob is bigger. Nope. Look at them. So good. It's a square. Okay. So let's go ahead and put a breakpoint in our code and see what's happening. Clearly, we didn't get it right the first time. Womp womp. What's up? Kamal, Kamal. Alright, so what we're going to do is we're going to put a breakpoint in here. We'll just put it right here. Seems like a pretty good spot to put a breakpoint, right? And let's see what's happening. So we're going to go ahead and hide this again. The game run. And we're going to hit the thing. We're here. Bada bing, bada boom. Welcome to debugging. Debugging is a large part of coding. Let's have F11. Go in the method. And let's see how this worked out. So, how much pollen should we have right now? We have 10. Why? Because the combo level's 1. Great. Our launch segment, I would guess, would be 60. Or no, 36. 360 divided by 10. Beautiful. I'm hovering over it. It says 36. You'll just have to trust me. Now we're going to go through our number of pollen, which is 10. And we're going to create 10 new pollen. Our current pollen, just want to make sure it is indeed empty. Cool. So I'm just going to go to the end of here. I'm going to click continue. And then at the bottom here, so you guys can see it, we're going to put a watcher. I'm going to move this over. Actually over here, just so you can see what's going on. And then we're going to put in current pollen. Now it's pretty small. Let me see if I can zoom in here a little bit for you. Can I zoom in? What you need to do is go to your monitor and go like this. Hello. Do I vibe code? I'm not sure what you mean by that. So we can take a look at everything in our object here. We see that we did create 10 pieces of pollen. Beautiful, that's what we wanted to see. If we go to any one of them, it's showing all the beautiful stuff about it. If we scroll to the bottom, we can see some of the stuff that we put in. You can also see there's way more than we needed, which is what I said when we created this type of object. It looks like we did get the height and width, which is great. We got our sprite box, great. It looks like everything's put in. Yeah, everything's pretty good. So now what we're gonna do is this stuff was just created, so we know the stuff's gonna be going on for a second. So let's go to the pollen class and see what's going on. I think it has to do, of course, nothing was moving. So that's problematic. So let's go here and put a breakpoint there. Click continue. Now I'm going to have to just tell you what's going on here, because again, on hover it doesn't say anything. Our current position is the position that we put. It's an 8-8 from the core position of the thing, the flower. So if I click F10, what is our projected position? Is it any different than our position? 232, 168. Our projected position is 232, 168. Why? Our degree launch angle, 36. Our radius is 0. Oh, we need a radius. That's fine. If you don't have a radius, it's not gonna move. Wait, what did we put for the missile? Where did we set the radius? Oh! It's constantly increasing the radius. Oh, yeah, that's why I failed. Where did that go? Between previous position. Oh, we didn't even put that in either. I don't even know if we need it. Radius, sure. I want it to be dramatic so we can see it. We'll just make it like, I don't know, 0.2. If that was 0.4 and it was moving slowly. All right, so now we have our launch angle, we have our origin, our radius. All right, let's try it again. I should just turn off the sound by default right now. To do this every time. Alright, let's see what happens. Yes, we hit a breakpoint in the code because I forgot to take it off. It's looking weird again. What? Whoa! There was a thing. Did you see the thing? I saw a thing. Whoa! Whoa! Well, that looks trippy as anything. Whoa! There are so many. That looks like way more than 10. Wait, what's my combo at? And why are they 16 by 16? I said they were 3 by 3. Alright, they're not moving nearly fast enough. It's pretty interesting. It looks cool though, right? That's pretty cool. Ooh. Zoop. Neato. Zoo. Alright, so what we can do, we can pause the code. I'm wondering why it's 16 by 16. I think there's somewhere where I'm drawing it wrong. So let's pause this. We'll go back. Pause it. I think when I'm drawing it down here, I think I'm drawing them to 16 by 16s. I am. That's why. It was easier to see them though. So we're down here. We're in the draw class for pollen. Alright, we'll make them 3 by 3s, I guess. The proper size. Okay. Now again, it's moving way too slow. But we also probably want it to last longer just so we can see it. So why don't we change also the time here. Let's make it 2 seconds instead. And oh, the radius. So the radius is kind of how fast, well, the speed is, the circular speed as well as the radius. The radius, I think, is how far it's going to move, as well as the speed. Why don't we make this 0.15 like that. And we'll just do 0.25. We're just messing with stuff. Just pushing buttons. And I think we'll be fine if we just continue. Let's restart the level. Oh, 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 that was cool. All right, you ready for this? Whoa. Alright, let's see if we can add more. I did a bad job at playing the level. I don't know why they're faded. Ooh, you see that? That was really neat. Woo! It's a beautiful circle. It's doing the circle thing. Look at these cool circular little spinners we're doing. That's pretty neat. We can also do different colors too. So I'm just gonna throw in some other colors here. Try out the other colors. We got orange. We got blue. Alright, so now we're green. And go. Boom. Ooh, greenies. It is interrupting it, which is good. Nice. Look at that beautiful cyan. Nice. Looks cool. Neat. It's not exactly what we want, but it's pretty cool. So, one is the reason that it has it's not fully colorized is because I copied this class from the light class, and the light class was using transparency. So that's a really easy thing for us to fix. Got about 10 more minutes today too, so I would love to get to a little bit better spot before next time. Maybe a little bit longer today, but a little bit before 1 today. So when we're drawing these guys, where are we drawing them? Here. Here. Somewhere we're saying, is it false here? Or opacity. We're setting the opacity to less opacity, but I'm trying to see where it is here. I actually don't see it here. Is it when we're instantiating the sprites? No. I'm just gonna stop it. Draw. Our opacity. Yeah, we're not passing in a lower opacity. So if we go to the light objects that we copied this over from, this class when we originally created it, go to light beam. These light beams are supposed to be opaque, which they are. Raw. Oh! I know. When I was taking the positions, I wasn't taking the positions of these. I was taking the positions of these. So we're taking positions right now of these, which is why it was also a static color. So and that's why it was also transparent. So I was taking it from these spots. These are the colors that I was using. So if we want a mix of color here to make it look a little bit more jarbly, we just need to add 16 to it. So I was taking something from like around here on the sprite sheet. So instead of 144, which is right around here, right? Yeah, 144. We'll just do it from around, I don't know, 164. That's funny. Opa. Oh, I'm messing with light beam. Don't do that. Wrong class open. Okay, here we are. What was I? 160, man, 8, right in the middle. Okay. So they're doing this little spiral thing, because that's kind of what we're doing, is we're doing a radial circular spiral going, which is pretty neat. Now what I kind of want to do is it to be quicker. It's not just that it's moving faster around the circle, which is the circular speed, but it's actually moving out further, which I think is the radial speed, how fast this radius is moving out. So I think what we're going to do is we're going to modify the radius to go a lot faster. We're going to say like 52. We're going to double it. And the circular speed too, I really want it to go. So why don't we even make that twice as fast as well? And see what that looks like. We got the game going on here. And let's just choose a different one. Let's choose this one. Come on now. Okay, so this one we're gonna have yellow. Whoa! Zoomies! That is... I mean, it's going. Alright, let's see what happens when we get a bear combo. It's so fast. I mean, it's pretty cool, right? Now the animation, the radius is still not moving quite as fast as I want. And of course we know 2 seconds is way too long. Like, this is supposed to be like an instantaneous effect that's affecting the bricks around it. But it looks real cool. Try it again. Let's get its combo level up really high. So what we're gonna need to do eventually is tie how fast and far the radius is with how far it actually is moving. So if I really want these to go wild, I can just add some more bricks here, just for funs. Let's add a bunch more. Let's get our combo level up. See what it looks like. Whoa! Pretty cool. So that's kind of where we're at. I think that's a good place to stop. So basically we've proven that we can do like an angular sort of circular motion, which is what we want. We're going to want the radius to be faster. So we're going to want it to shoot out further. We're also going to need the radius to actually be the amount of bricks that it's affecting. And the circular speed of these things probably dictating as well how far it's going out. And maybe like probably mess with the amount that I'm spitting out as well. But right now, pretty cool. They win. that was good progress today. Thanks for all tuned in today, hanging out, watching some coding, watching some design work. Next time we do some coding, we're gonna fix this up, make it so that how big the pollen gets shot out actually corresponds with the combo level and the radius. And we'll move on from there. Probably actually put in the flowers and some other stuff like that to flesh it out. That'll be it for now. Might do that tomorrow. Might go back to a new randomizer or some OOT. We're going to have time practice tomorrow. We'll see. But again, thanks for tuning in. I'll see you guys next time. As always, love you. Jesus loves you too.